I will start this session. And here is my second conference. So I joined Samba XP conference last June. So I get many valuable comments and ideas from there. And I am here after updating them. I'm happy to announce more upgrade CIFSD at Storage Developer Conference. I will talk with the following topic in order. From now, I would like to talk with CIFSD introduction first. Currently, Linux has network file systems such as kernel NFS client and NFS server and user space server NFS Ganesha. And SM protocol implementation include SMB client CIFS and user space Samba. Unlikely, NFS and SMB server for kernel is not supported yet. CIFSD has different things compared to existing SMB server. And we hope that CIFSD fill the blank for SMB server that was not provided by kernel yet. CIFSD supports all SMB versions up to SMB 3.1.1 from SMB 1. SMB 2 can be set to SMB 1, SMB 2 can be set to optional in configuration and disabled by default. There is one unimplemented command in CIFSD, which is SMB2 notify command. SMB notify command that send notify event to client when file or directory in share is changed by local server or another client. And we are planning to implement it using fs notify in Linux kernel. The problem is that fs notify functions are not exported yet. We are currently requesting this to be exported to RDMA. CIFSD supports the following feature, so we try to implement the performance and security related feature that our user wanted. In addition, I try to implement a feature that other SME server cannot implement or not supported yet. NTLM and NTLM version 2 are supported for authentication now. And cover support is our to-do list. And CIFSD supports OPRAC and lease and compound request and copy upload, and SM direct is supported. And for security feature, CIFSD supports and signing and data encryption features. We have been currently maintaining CIFSD and CIFSD tools on GitHub. This is the address that manages CIFSD and CIFSD tool, and we are leaving the patch and discussing on the mailing list provided by SourcePorgy. Please visit our GitHub and you will find out how to use CIFSD and join in CIFSD development. Supported Linux kernel version is from Linux 4.1 kernel to the latest kernel. If you want to join CIFSD development, please subscribe to Linux CIFSD mailing list and Git clone and our Git repository, and you can send bug report or patch or any idea to mailing list. We provide build step of CIFSD for each Linux distribution, and we guide both standalone build step and a part of kernel build step at there. And you can easily set up CIFSD on your target if you check out our GitHub. CIFSD recently built in test automation. There are several CIs, but we chose a Travis CI to be possible to integrate with GitHub. By using Travis CI, we can automatically test patch in pull request. And test consist of build test and stability test. Travis CI will do build test with 4.1 kernel and the latest Linux 3. Then Travis CI run except test and SMB torture test case to check stability issue in the patch. Test automation let we find the bug in pull request in advance. After resolving them, the patch will be merged into CIFSD to keep it as stable as possible. Implementing all RPC code into kernel is too large and heavy, so we need to minimal command implementation to work as a Pi server in user space. Then processing to generate this RPC response is done in user space and passing over to CIFSD kernel thread. CIFSD also has the ability to configure server. Like Samba, user should write parameter in SMB conf file. Parameter format is almost compatible with Samba's one. This is to make CIFSD as easy as possible for user familiar with Samba. There are many configuration parameters in Samba. I saw everything was difficult and unnecessary to implement at once. We implemented them which selected the parameter that user commonly used to operate as Pi server. And we added more parameter that requested by real user. And we list of supported parameter list in SMB conf example file in CIFSD tools. SMB1 in CIFSD disabled by default due to security risk. Windows 10 also make SMB1 disabled by default. However, there are some clients that have not yet switched from SMB version 1 to SMB version 2. So they are still working with only SMB version 1. Other SMB clients will eventually switch to SMB 2, but I think it will take time. So SMB version 1 in CIFSD is optional, and code can be easily removed. We are planning to post only SMB version 3 server that removed SMB version 1 when contributing to Linux mainline. OpenWRT project is a wireless router open source project. Recently, CIFSD was built in as an SMB server in this project. OpenWRT is already in use Samba. They are saying the following the reason. Samba has a crazy complex makefile and have to use QEMU to create cross-answer file for architecture and target. This is overall make Samba 4 one of the most complex and difficult package to create and maintain. In comparison, creating the CIFSD package was straightforward without any special handling. And they are saying CIFSD binary size is small. So CIFSD is suitable for embedded target which tend to have a small flash size. And OpenWRT users are reporting CIFSD is low CPU usage and better performance than Samba when running CIFSD on their target. In this chapter, I will explain the key concept of CIFSD. CIFSD is an in-kernel server. User space server requires a lot of system core for I/O. while kernel server doesn't need to do system calls, so system call cost can be reduced. Moreover, in-kernel server can be tightly integrated with VFS and network stack. We can expect to execute shorter paths and less instruction by directly using the VFS and socket API in kernel. And server should maintain metadata information of file and file system getting through local file systems such as inode or superblur in kernel. CIFSD can be used directly when it is needed without any allocation. It could reduce unnecessary memory allocation and memory copy. SMB drag feature has been introduced a long time ago, but other SMB server solution doesn't support yet, except Windows. In CIFSD, it was easy to implement it without any constraint. We are pleased to announce that CIFSD has SMB drag support as storage developer components. It is implemented by co-speaker Hyunchul Lee, and he will talk about SMB drag support on his chapter. Opera Lee's handling of CIFSD is better than Samba. Opera Brig is a command sent by server to make a client invalidating the cache and or flushing write data. Samba need IPC communication between SMBD process for Opera Brig request because they are in different address space on process model. While CIFSD can send Opera Brig request by managing Opera and leads with global data without any IPC. We will show performance difference on the performance chapter. The latest Samba source is over 150,000 lines of code. Kernel server should be a minimal function server. NFSD with SunRPC has 60,000 lines of code. Without SunRPC is about 30,000 lines. CIFSD has 40,000 lines of code, and only SMB server CIFSD has 30,000 lines. Only CIFSD line of code is similar or less with NFS1. CIFSD is a simple and lightweight file share. OpenWRT developer Andy Wash is trying to merge CIFSD into OpenWRT project. He reported that CIFSD is suitable for embedded target. She shared the table to compare binary size between Samba and CIFSD. Binary size of CIFSD is just 1 megabyte, while size of Samba is 6 megabyte. I heard that OpenWRT users have been using device with 8 or 16 megabyte ROM size. A minimal default install of OpenWRT is already 6 megabyte. Getting minimal package size is still a big priority in OpenWRT project because the user can install as many packages as possible. We will talk about CIFSD architecture and online component and their responsibility and communication protocol on this chapter. Initially, I implemented all functionality in the kernel. Steve French advised me to separate into user space. So performance-related features such as SMB engine and Opera leads and transport layer are going to server. Non-performance related features such as DCRPC and user account share management and compilation are separate to user space. This is to maximize performance and minimize kernel memory usage. We call kernel thread KCIFSD and call user space thread UCIFSD. KCIFSD will activate when CIFSD is launched, and walking by exchanging information between two demos at runtime. How does CIFSD communicate between kernel and user space? CIFSD uses NetLink interface. NetLink is used to transfer information between kernel and user space. It consists of a standard socket-based interface for user space process and kernel API for kernel module. We specify the following few command set to transfer data between KCIFSD and UCIFSD thread. This shows entire architecture. We provide CIFS user add util to store user account password information to DB file. User need to write some parameter to SMB comp for configuration. When running CIFSD, KCIFSD focus thread in kernel will start to open 445 port and listening new client connection. UCIFSD send global metadata, global parameter in SMB comp to KCIFSD through NetLink. If a new connection is coming, focus thread will fork new KCIFSD1 case thread as for connection. KCIFSD1 thread will receive the SMB request and send the SMB response until the client connection is terminated. The slide shows entire CIFSD component. Transporter IPC is a component for communicating with the user space CIFSD using NetLink interface. The server component is the core part that handles request response and CIFSD server initialize and release. Transport TCP component consists of function to send receive request response through socket. Transport SMB component is consistent of function for RDMA send receive. SMB engine is component of pass SMB request and make SMB response. And OAuth component is for processing authentication. The VFS cache component is for file and inode handling. And KCIFSD can access the local file system via VFS abstraction component. On this chapter, we will show performance comparison with the benchmark tool. Performance is measured using Jeon and PyROPI and BenchOpera. We use TempFS as shared directory and measure performance on direct connection between two PC, reduce result error. And Opera release is disabled to avoid caching. We use the kernel CIFS client. This is a single read write Jeon result. It showed that CIFSD was 4% to 10% faster. This is a multi-read write Jeon result. This shows CIFSD was 3% to 15% faster. PyROPI is a tool to show performance as number of file operations that can be performed per second. I think it is good benchmark tool that evaluates the overall file system performance rather than measuring simple read-write performance. As a result, that PyROPI CIFSD was estimated to perform 9% to 37% faster overall. The hard disk sizes grow every year, and there are users who store a lot of files in one directory. The speed of browsing file will be an important factor. So I use the ls command as shell to compare file lookup performance. The CIFSD was estimated to perform 30% to 44% faster than Samba. The Opera bench results also show a big difference. This is maybe not an advantage as CIFSD is working in kernel, but rather an inevitable performance regression in process model. We measure CPU usage between Samba and CIFSD. While playing 4K movie, we measure the CPU usage for 2 seconds using mstat util on server side. As you can see in table, Samba CPU usage is swing between 2.7% and 5.7%. In comparison, CIFSD CPU usage swing is between 1.7% and 3.7%. After playing the movie for about 10 minutes, the CPU usage average of CIFSD was 2.8%, while CPU usage of Samba was 4.2%. We conclude CIFSD CPU usage of average is 32% lower than Samba. We have checked the compatibility with various SMB clients, all Windows versions and Mac OS and other Linux clients. I have tried several tests connecting devices of respective OS. So CIFSD provides the SMB compatibility with the OS in the following table. SMB torture results show 95% pass rate except fail for unsupported feature. In the case of XF test, it is 100% pass rate with CIFS client in 4.16 kernel. With CIFS in the latest kernel, some test case failed due to problem with the FS control, punch-hole, and zero range, and so on. We will fix them after this conference. There are great features of our latest CIFS client. We want to CIFSD to make the perfect pair with CIFS client. So we are catching up the feature supported by CIFS client. CIFS and CIFSD code are very similar, and so it is very good to reference the new feature and easily take it. So I said on previous page, we catch up SMB direct from CIFS client first, and it also add the project extension, which is being discussed recently. CIFSD was supporting AES GCM encryption, so we also complete to implement the GCM encryption. And like CIFS, we increased the max read-write buffer size to 4 MB. And as we said on previous page, we applied to test automation with Travis CI, while CIFS uses buildboard. CIFSD encryption performance can be improved with hardware acceleration on the kernel. If your CPU supports AES-NI, and it will already be enabled and automatically in small module in your Linux distribution. If you are manually build your kernel, just enable AES-NI module in your kernel. Samba proposes CCM over GCM. GCM seems to be faster than GCM in current implementation of Samba, but GCM performance with AES-NI is more better performance than CCM. So Windows prefers GCM over CCM. As I said, GCM encryption of CIFSD is supported with AES-NI. So, and user can use better performance with CIFSD on data encryption connection. Yeah, SMB direct part chapter, Hyunchul will talk about this chapter. Yeah.
Hyunchul from LG Electronics. I'm going to talk about what SMB Direct is. And
the microphone is not working.
Hello, I'm Hyunchul from LG Electronics. I'm going to talk about what SMB Direct is, the implementation of SMB Direct in CIFSD, and show read-write throughput. Before I start, I want to say SMB Direct could be implemented quickly because of CIFSD client developers. SMB Direct is a new transport protocol for supporting SMB over RDMA. It's introduced in SMB version 3 and implemented in Windows Server 2012. SMB Direct operates over reliable RDMA transport such as Infinity, ROC, and iWarp. Reliable means it is guaranteed that messages are delivered at most once in order and without corruption. Because RDMA transfer is message-oriented, unlike TCP, SMB Direct defines framing for SMB exchange. And there are 3 types of SMB Direct messages, which are negotiation, request, negotiation response, and data transfer. Data transfer message contain a whole or a part of SMB message. SMB Direct use RDMA send-receive operation per SMB exchange, which is a datagram type send-receive, and before a sender send a SMB Direct message, a receiver have to pre-post receive buffers. And due to resource limitation of RDMA network card, a receiver can post the limited size and limited number of receive buffers. So before SMB exchange, a client and server have to negotiate per maximum size of buffer which they can receive and how many empty buffer they have. The latter is managed by credit management. Each peer sends SMB Direct message with the available number of buffer in header of SMB Direct. If SMB message is larger than the size of buffer, the message have to be segmented into SMB Direct message and resembled. File data is not included in SMB message. A client sends SMB request with the memory location, which is store write buffer or will be store read data. Server use RDMA read-write operation to transfer data between client memory and server memory. Currently, CIFSD doesn't support multi-channel, so if a client wants to connect CIFSD with the SMB Direct, it have to connect to port 5445. Because CIFSD defines interface of transport layer, kernel thread CIFSD can receive and send SMB message without knowing which transport layer is used for being connected with a client. To send SMB response to a client, a server checks that it has sent credit granted by the client, which means client has empty receive buffers, and server generates one SMB Direct message from the SMB message. If SMB message is large, the server repeats these 2 processes. During this process, if server don't have send credit or the number of pending SMB Direct message exceed a threshold, the server posts RDMA send operations to send all of pending SMB Direct message. Finally, if SMB Direct message are arrived, the client resembles this into SMB3 message. For file write, unlike TCP, client doesn't send file data with the SMB write request. Instead of it, client lays the buffer and send the location of the buffer within SMB write request. Server posts multiple RDMA read operation to get data from the location of remote buffer, and bulk of data is transferred by network card on each side. To support large size per request, the server can post multiple RDMA read operation or register buffer as a memory region to RDMA transport and post a few of RDMA read operation. To limit RDMA resource, we limit the number of running RDMA read write operation to 8 and set default maximum size of read write to 1 megabyte. Our test setup is not the latest. Two PC have Intel 3rd generation i7 and 16 gigabyte RAM and 10 GB Mellanox Connect X2. We connect to PC directly and mount CIFS with Linux kernel version 5.2 CIFSD client, and we run FIO with change on the block size and the number of IO thread. And we make CIFSD operate over temp FPS. On the x-axis, plot the buffer size of FIO, and on y-axis, plot throughput in megabyte per sec. The peak throughput is 1,106 megabyte per sec when buffer size is 1 megabyte and number of thread is 16. As the number of thread increase until 16, throughput also increase, but more than 16 thread make throughput be lower because we set maximum number of running RDMA read write operation to 8. The reason why throughput increase until 16 thread, not 8 thread, is that while a thread is waiting for SMB response, RDMA read for another thread can be posted. Anyway, throughput decreased largely with 256 thread. There is a contention issue, and we have to plan solve this problem. And as buffer size increased, throughput also increased. But if buffer size reach 4 megabyte, throughput doesn't not, because we set maximum size of write to 1 megabyte, and 4 buffer means the number of FIO thread increase. This is a reason why throughput increased with 1 thread and 4 megabyte buffer size. The read peak throughput is 1,122 megabyte when buffer size is 1 megabyte and number of thread is 16. Read throughput is a little larger than write throughput. A change on the buffer size and number of thread is almost the same with the write throughput.
And our next plan, we will set up the Windows protocol test suite and improve the CIFSD compatibility and stability more. And we will implement the SMB2 notify command with SMB notify, which is exported. And Samba team asked if CIFS support WinACL or not. So we will do it with more higher priority. And we check the SMB Direct with only software Rocky and Mellanox 1 NIC. So we need to check the compatibility with the different NIC. And we will check and support multi-channel like CIFS client. Yeah, the end. And thank you. Any question? Yeah, this is open source. And GPL version 2. 2 or later. Yeah. 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 Yeah, I hope, but I need to uh, discuss an observer from SMB developer and maintainer. Yeah, so I am closely to discuss with Steve Frenchy and Jeremy Allianson. Yeah, so maybe they are thinking CIFSD is ready. I think that I can contribute to CIFSD to into mainline. Yeah. Yeah.
So thinking about this at a high level, obviously community process, one of the things people are going to ask is, maintainability. The more people involved, the better. Because obviously outside this room, people worry about random stuff being dropped in. I think this is good. We have lots of people involved. The second thing is not the stability. You want it stable. You want it stable enough to evolve. So I don't think we have to worry about it being perfect.
Yeah.
So I'm not worried about passing every SMB torture test, and I don't think anybody in the community will. It's the maintainability and a long-term purpose, and some of these, I think, this is good progress. But I think that what's super important is, all these people giving you feedback on anything that they see that's a red flag. Because right now, the things are fairly minor that we're talking about to fix up. But this is the week to just ask anybody to come to you with last-minute requests, because I think they'll be concerned about maintainability and going forward. I mean, it sounds like a fantastic experiment. But remember that we have to kind of sell this to a community that can't spell SMB.
Okay. Yeah.
You had a slide that mentioned you were compatible with various OSs, one of them being like the Mac OS. What was your criteria, or what test did you use to come up with that it's compatible?
You are saying Mac OS version, right?
Right. I mean, you had a slide that said we're compatible with all these OSs, but you didn't actually say how you actually tested that you were compatible. This one, yes.
Yeah. And I checked this, so only 2 Mac OS, and as I remember, it's High Sierra and under version one more. Yeah.
Well, the question is, what exactly defines what you consider to be compatible? I mean, what did you do? Did you just Namjae share and then that was
Yeah. So yeah. I connected my MacBook is connected with the CIFSD and read write and file delete and rename and some of things. Yeah.
So it's just mainly manual ad hoc testing.
Yeah. So I can how to the how to the hard test in MacBook. Yeah. So if there is some stress test tool in Mac OS MacBook, Mac OS, so I can run it. Yeah. But when I test and manually, so I cannot find any issue. Yeah.
Did you bring a server to the blood test downstairs?
Pardon?
Do you have a server with you that we can play against in the blood test downstairs?
Yeah, I didn't. Yeah, but yeah, if you want, so I can show you that at there. Yeah. Yeah. Okay. Yeah.
I have 2 questions about the SMB RDMA testing. Test with Windows?
No. Only CIFS client.
Really?
Yeah.
You should test with Windows. Okay.
Yeah.
Second question
Yes, people send SMB, RDMA send operations. Uh, I acquire send credit.
Yeah, referring to the SMB direct credit that maps basically to an RDMA receive permission buffer. And you imply that, let's say you're going to send a megabyte, right? You're going to need a whole lot of messages. Do you wait for all those credits before you send?
No.
No. Okay.
Yes.
So you send one credit at a time.
Yes.
Good. That's unclear from your picture. Okay.
Okay.
I think you said you support only NTLM V2, is that right?
Yeah.
Do you have any plans for supporting Kerberos? Because NTLM is kind of the easy game there. Kerberos means you probably bring in a lot more stuff into the picture, like AD and whatnot, all this other stuff. So is there any plan to support other authentication protocols?
Yeah. So I think the Entire version 2 is widely used still. So
Yes.
yeah, I saw it is sufficient for current users. So, but I don't think Kerberos is more seriously. So okay. So if you more is why Kerberos is more Kerberos is needed for SMB server. I can. Yeah.
So as an example, whether you like it or not, there's this thing called FIPS. So in some government accounts, for example, Red Hat is built without some of the algorithms needed to run into MV2, into the MSSP. So whether we like it, some Red Hat distros, for example, are built without the libraries you need to do anything other than Kerberos. So it's annoying, but we do have some cases where Kerberos has to be used because the algorithms are removed from the distro for security reasons.
And yeah, the reason for that is NTLM is known to be crackable with modern hardware, but even NTLM V2, and that's why people prefer other. So that's something which you might want to consider at some point.
Okay. I
Because
see.
even at Microsoft, we are trying to kind of deprecate, or at least it's not easy, but we are trying to get out of this NTLM business. It's a long-term goal, but that might be something which you want to consider.
Yeah. Okay. I see.
And you said you do not support multi-channel, right?
Not supported yet, but we are planning.
So that might be one of the reasons why we could not test it from an SMB, like a Windows client, because we need multi-channel. Yeah,
You can turn it off on
Yeah.
the client. That's negotiable. Yeah.
no. You can't test RDMA without multi-channel for our clients, because we use multi-channel to discover RDMA.
Right. We're on the CIFS kernel client, you can just force
Right.
RDMA.
Yeah. So that might be one of the reasons, I'm guessing.
So port configuration, one of the things that might happen, for argument's sake, is that you might be testing your kernel client, kernel server, excuse me, and maybe Samba or something else on the same box. On the kernel client, it's easy to mount with port equals. If you can start your service with a different port, then you wouldn't, so you could have both Samba running and yours running on the same box on different ports. If you're trying to not collide with somebody else. Is it possible in your config file to specify a different port than 445?
Yeah. 445. Yeah.
So you can use a different port other than 445 by changing the config?
We can change the port. Yeah.
Okay.
Yeah.
Because that would mean that you could run Samba and yours on the same box at the same time. Test.
Okay. If there is no question, so I will end of my session. Thank you.